So not a function. And then number 2 and number 3, is it a function? Remember, a function passes the vertical line test. So number 2 definitely passes the vertical line test. But number 3 does not pass the vertical line test because the x's repeat themselves. On your test, I'm going to give you some pictures similar to this, not the exact same one. And the directions are going to say, determine whether each relation is a function. If yes, state whether it's one-to-one, onto, both, or neither. How do you tell if a function is onto? I'm not onto. One-to-one. Right, a one-to-one function, all the x's are different and all the y's are different. So, easy to tell if it's one-to-one if it passes both the vertical line test and the horizontal line test. Right? So the only one that was a function was number 2. Does number 2 pass the horizontal line test? Does that pass the horizontal line test? That means the y's repeat, right? The y's are always 2 here, so the y's are repeating. So this one would not be one-to-one. If it's not a function, it can't be one-to-one. So if it's no, you don't answer that. The other one we talked about is onto. Remember what onto means? Well, onto means that like all the y's are used, right? And so it's kind of weird with the graph, and I feel like you could argue the case either way. So I'm pretty sure you can say every function is onto, and you would get it right, because you can say it's onto over its specific range. So like on this graph, for the range of this graph, every y that's in the range is used. I like to say this is not onto because not all, like I think of it as all the y's are not used. Like on this graph, you see that there's like this y is never used and this y is never used. You know what I'm saying on that? I think you could argue it either way, so you can just kind of decide. Do you want to say it is onto, or do you want to say it's not onto? Based on. So like for me, I would have said this is neither, because it's not one-to-one, because the y's repeat. And I would have said it's not onto, because the only range values on this, you agree our only range values are 2 and -2. So there's a whole lot of y values that aren't being used. You see what I'm saying? So to me, if the y's have values that aren't being used, I say it's not onto. If you want to argue that it's onto for that range, then you can say it's onto. So mostly you. Okay. What about 4 and 5? Did you get 4 and 5? I would suggest on number 4, show me some work. So in case you did some order of operations wrong, right? Remember, you're just replacing x with -3. So you would get 10 times -3 plus 3 times -3 squared. And we've talked about this. You just type -3 squared in my calculators. It says the answer is -9 because it's squaring it and then it's putting the negative on it. So either put it in parentheses or know that that's a +9 because that really is +27 times 3. And then 10 times -3 is -30. So that's how they get an answer of -3. And it throws people off when there's a letter there, but all you do is g of x, you replace the x with the a. So notice it's exactly the same thing, we just changed x's to a's. And I'll tell you that on your test tomorrow there are 2 questions. I give you an f function and a g function. One of them I'm going to give you a letter, one of them I'm going to give you a number. They're just different ones than this. So like, we can circle all the ones you know for sure are going to be similar questions on your test tomorrow. 4 out of 5. So 6 and 7, is it linear? There's going to be a few multiple choice questions, and the multiple choice would be the linear part. Like, I'll give you a multiple choice question and ask you, like, which one is linear, which one isn't linear, instead of just being like this. Remember, to be linear, x can't be in the denominator, x can't be multiplied by y, and you can't have any weird exponents. So, number 6 is not linear, because you can't have an x in the denominator. Number 7 is linear. Questions on those? So you could circle those, but those are multiple choice. I don't know how you do it. I don't know what this is. Number 8 would also be a multiple choice question. I would give you an equation and ask you to pick which one is in standard form correctly. Standard form, the big thing you have to remember is you are not allowed to have fractions, right? ax plus by equals c, where a, b, and c are integers, so no fractions. A has to be positive, X and Y have to be on the same side. So on number 8, if you left fractions in that, that's why your answer doesn't match this answer. So if you were going to get rid of that fraction, remember you have to multiply by the denominator. So the first thing you should do is you should multiply everything by 2. And if you do that, you get 5x minus 18 equals 16y. So that's where they got these numbers. But then notice they moved the y with the x, so they subtracted 16 over, and they added 18. I will not ask you to list A, B, and C. I just want you to be able to recognize which one's in standard form, so we can also say. Number 9, there is a question on your test just like number 9. The only difference is I changed the equation, but the directions say find the x-intercept and the y-intercept of a different equation than what's right here. Y-intercept, you can put it in slope-intercept form, but to find the x-intercept, you have to know that you have to just plug in 0 for y, right? Remember on the intercept, the other one's always 0. So I always remember just plug in 0 and solve it. So if I plug in 0 for y here, I would get 0 equals 2x minus 6. And then I'm just solving that equation. So I add 6 over, and I get 6 equals 2x. I divide by 2, and I get x equals 3. That's the point on the x-axis, where x is 3 and y is 0. Or you can just write it as 3, x equals 2. The y-intercept, you could put it in slope-intercept form, but again, the y-intercept is when x is 0, because on the y-axis, x is always 0. So just make this one go to 0, and look what you're left with. 3y equals negative 6. Because the x went to 0, divide by 3, and you get y equals negative 2, or that would be the point, 0, negative 2. X, y-axis, x, y-intercept. Questions about that? The one thing that I feel like there's not enough of on this little practice test is graphing. There's definitely going to be more than just 3 graphs on your test. All 3 of these are inequalities. There will probably be about 3 inequalities on your test. So we can like circle these. And we're going to say more graphs plus domain range. Those will be equations. On the inequalities, you don't have to see domain range, but on the equations you will, and I'll have those in separate parts of the test. I'll say graph each inequality, and then I'll say graph each equation, take domain range. So for 10 and 11, those are just lines, but you had to put them in slope-intercept form. 11 is definitely tougher than number 10. For number 10, all you have to do is add the 3x over, so you get y is less than or equal to 3x plus 2. So a y-intercept of 2, a slope of up 3 over 1, or down 3 back 1. It's a solid line, because the line's underneath it, and less than we shade below. This one, first of all, my graph is labeled wrong, because it says negative 2 down here and positive 4 up here. I think that's supposed to be a positive 2. They told me their graph doesn't even have a number on it. Does yours have a number on it? So, anyway, I was freaking out because I thought I did this wrong. Number 11 is really gross. Like, maybe you just want to take an XY chart on this one. But if I was going to put this in slope-intercept form, there's a lot of things going on. There's a fraction in front of the y. There's actually a negative in front of the y. The y is on the opposite side than it normally is. So there's a lot of algebra going on in this. The ones I give you on the test tomorrow, I don't plan to give you one with as many things on it. So what I did is I moved the 2 over first. So that's a plus 2. So I subtract from both sides. And I wrote x minus 2 is greater than or equal to, everything that's left over there is negative 1/2 y. And then I wanted to get rid of that negative 1/2, and it is multiplied, so maybe you could say I'm going to divide by negative 1/2. That, to me, looks really gross. So when I see a fraction, I always multiply by the reciprocal. So if that's negative 1/2, to get rid of it, I would multiply by negative 2 over 1. Think about that would cancel. And I also have to multiply this side by negative 2 over 1, if you want to say that. So then I get negative 2x. Negative 2 times negative 2 is plus 4. But because I multiplied or divided by a negative, whichever way you did it, you have to flip your sign. So that changes to less than or equal to y. So that was a lot already in and of itself. But now look, the y's on the opposite side. So if you do that shortcut where less than means shade below and greater than means shade above, that only works when it's in like y equals mx plus b form. So you have to flip it. So like you have to move the y to this side and then negative 2x plus 4 to this side. So that means the open side has to be on the y. You have to flip it back in here. Again, that one was a terrible problem. So if your graph was off a little bit, check and see what you missed. Did you forget to flip the sign? Did you miss a negative? Did you mess up get rid of the negative 1/2? Like think about the algebra there that you had to do. But now that should have a y-intercept of 4 and a slope of -2, and it should be greater than from all that flipping that we did, which is why you should be shading above that solid line. Think about that. Also, number 12 is an awful absolute value graph because it has this number on the inside multiplied that we don't normally see. But again, I'm looking for that you can make an XY chart and you can pick some points there. If you're not good at knowing which point to start with, know that the shape is a V shape and pick points until you get that V shape. So if you start with like 1, let's say you start with 1 on this one, you pick 1, 2, 3. All you're going to get is this side of the graph. Don't just make a line, right? If you just keep getting bigger numbers, pick numbers on the other side, like pick smaller numbers, or if you keep getting numbers this way, pick bigger numbers. So think about your graph when you're doing this. Normally, I say start with what makes this go to 0, which isn't usually as difficult as this, but in this case, that would be 1. If you plug 1 in there, you get -2 plus 2, which gives you 0. If you pick a number on either side of that, 0 and 2, you should get both parts of your V there. Because 0 is going to give you 0 plus 2, which is 2. And 2 is going to give you -4 plus 2. Yeah, so that value of that is also 2. So this one is dotted because it's not included. You graph that, it should be shaded in the middle. This question would be worth 5 points. Here's where the 5 points come from. 1 point if you remember it's a dotted line. 1 point if you shade correctly. 2 points if you have the graph in the right spot. 1 point if you made a V-shaped graph. So let's say you messed everything up, but at least you made a V-shaped graph, you can still get a point. Let's say you made a V-shaped graph and it was a dotted line, you can still get 2 points. So don't leave something blank, even if you get stuck on it. Like, show me that you know something about it so I can give you some partial credit as you're doing your test. Okay? Are there questions about that? Again, we'll talk about some graphs in a minute that aren't on here that you're going to have to know. Number 13, I'm going to circle this one, but it is definitely going to be different on your test. But it says, what type of function is represented by 2x squared? X squared is a parabola, so that's a quadratic graph. I'm going to give you 4 equations, and I'm going to give you 4 graphs tomorrow, and I'm going to make you match them up. So, like, it could be a step function, a quadratic, an absolute value, a linear function, just different ones. And if I give you the equations and I give you the graphs, it should be like process of elimination. If it's a V shape, you know it's the absolute value. If it's a U shape, you know it's the quadratic one. So similar to that, but like a little bit more involved there. And then 14 through 17, being able to deal with linear equations. Not all 4 of these are going to be on there, but definitely you're going to have to be able to write an equation given a point and a slope. You're definitely going to have to write an equation parallel or perpendicular. Yes, we're going to talk about Wanda thinks it's wrong. Do you agree with that? That's about to say. Yes, there's a wrong answer up here because you can't trust the book all the time. Number 15, first of all, this is not the right answer. I'm not going to give you a question to ask that, but I might ask you to talk about graphing something with perpendicular or parallel. So maybe I'll just circle on this. First of all, 14. Anybody have a question on 14? Finding the slope, subtract the y's on top, x's on the bottom. I'm not giving you a question on your test, just asking you for slope, but you have to find the slope to write some equations sometimes. So, you need to know how to do that. But number 15 says, what is the slope of a line that's perpendicular to y equals -3? Y equals -3 is a constant function, so perpendicular to that should be a vertical line. And Mackenzie, what should this answer say? Yeah, that has an undefined slope. Not a slope of 1/3, so I'm not really sure why the book was wrong on that, but they're wrong. It is a reciprocal of that, but it's not the right answer, right? because isn't this line looks like this, right? It has a slope of 0. So if you make the line perpendicular to that, doesn't that look like a vertical line? So that's going to be like some number over 0. Like any number divided by 0 would be your slope, because you're not moving any left or right, so that makes you have 0 on the bottom. So anytime you have 0 on the bottom, that's an undefined slope, which is vertical. 16 and 17, both writing an equation in slope-intercept form. If you didn't get those right, remember that this form of the equation is probably what you're going to be using. Point-slope form, because if they give you a point and a slope, you just plug it in. So like number 16, just to show you, if I plug this point in, this is my x1, this is my y1, this is my slope. So I would say y minus -5 equals 2 times x minus 1. It does say to put it in slope-intercept form, so you can't leave it like this. So you distribute 2x minus 2, and then when you subtract that 5 over, that's where they get the answer of 2x minus 7. Number 17 is identical to that. The difference is they don't tell you the slope. They tell you that it's parallel to this equation. And remember that parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So if it's parallel, you just need to find the slope of this. It's not in slope-intercept form. So the first thing that you should do is you should put it in slope-intercept form. So I subtract the 3x over, I divide by 2, and then I stop, because all I care about is what is the slope of that line. So I'm going to write an equation with a slope of -3/2 that passes through this point. And I would do it the exact same way that I did number 16. Now I would plug in my slope of -3/2 and my point, and it should work out that you get a y-intercept of 0 there, which is why the equation is just -3/2 x. If you wrote -3/2 x plus 0, that's okay too. But if you need help working that out, just okay? So definitely looking at that. Scatter plots, I haven't decided yet if this is going to be multiple choice or you actually have to work it out, but there'll definitely be some sort of scatter plots on there. Let's go ahead and again, maybe multiple choice. Multiple choice would be a lot easier, and you just have to match up which one makes the most sense. You probably be able to use process of elimination. Whereas if I don't do multiple choice, you actually have to graph this. So number 18, you should be able to look and see that your points are about the same. That's not so hard. The hard part is number 19. It says, use 2 ordered pairs to write a prediction equation. That's that line of best fit. So like you want to think about your line of best fit here, roughly speaking. Remember, you want it to like go through as many points as possible. You want the points above it to be about the same as the points below it. And then your answer could be different than number 19. But how do you know if your answer's close? Is if you predicted and got something close to 30, that's how you know if you did your equation right. So notice they tell us their answer, they use the very first point, and they use the point 10, 15, which is the very last point. And all they did is they wrote the equation just like you did up there, using those 2 points. So you have to find the slope. Like if you found the slope of those 2 points, you would take 15 minus 9 over 10 minus 6, and you would get 6 over 4, which they reduce to 3/2. And then that's your slope, and you have to use one of these points and write the line that's through there. So if I use this point, I could say y minus 9 equals 3/2 times x minus 6. And this actually works out not so ugly, because when you take 3/2 times 6, you get 9, right? 3/2 x minus 9. So when you add 9 over, the y-intercept ends up being 0, which if we look down, if we continue my line here, oh, I'm a little off from having a y-intercept of 0, but close. That's their equation, and they use not x and y. Mine would have been y equals 3/2 x. And then you predict how many goals would there be for 20. So you plug 20 in there, 3/2 times 20, and that's where they got the answer of 30. Anybody get close to 30? Anybody see that? and again, depending on which point you use, you know, like if you use this point, think about that your slope is a lot different. Or if you use this point, it's going to have a steeper slope. And so that's where I would just have to look at your, which is why this is 37. So again, it depends on how you put that in. But just a reminder, that's the process. Number 20, again, kind of goes with the matching up there that I said. It just says which one of these would it be. We could even be more specific because we talked about two set functions. We talked about the greatest integer function and the ceiling function. Which one would this one be, the greatest integer or the ceiling? Am I rounding up or am I rounding down? Down, because it's filled in circle and then over to open circle. And so you could even say that's a greatest integer function. I will tell you I'm going to give you one of those to graph, either a greatest integer or a ceiling function, and ask you to give me the domain and range. We spent a lot of time on that. We did those posters. The domain of every single function that we have done has been all real numbers. So your domain for your functions tomorrow should be all real numbers, which we wrote as negative infinity to infinity. And then think about those step functions. What makes them step functions is you only get integers out of them. And so they just wrote all integers. We wrote that as like y, such that y is an integer. So again, the one thing I would say that is not on here as much as I wish it was on here is the graphing. Graphing step function, graphing a piecewise function, that's not on here. It's on here. Saying the domain and ranges of those, and then just graphing the algebra equation would also be on there. Maybe even a quadratic with a solution would be on there as well. And then I think this was the same bonus that was on your quiz that you took, which was interesting. Questions about this right now? I'm going to give you your quizzes back, but here's what I want you to do. Studying for math is different than studying for other classes, right? Studying for history or studying for English tests, you can just go back through and read things. To me, I don't think studying for math is very effective if you just look at problems that are already worked out. Like actually practicing problems, knowing if you're right or wrong is helpful. So what I wrote on classroom today is that I want you to go to Khan Academy, and I think Jennifer just ended up to get her signed up for that. Everyone signed up for that class, or maybe both classes in here. And remember, one, I told you can get some extra credit if you complete 10% of those courses by one of those courses by the end of the 9 weeks. But two, Khan Academy is amazing for showing you how to do stuff. And so I put some suggestions of what to go to, but if you want to just get your computer out and go to khanacademy.org, I'm going to show you what I think you should go to on this if you're looking for things to study. Maybe you feel really good about most things except for piecewise functions, so you want to look up piecewise functions. Or maybe you're still really struggling with domain and range, so you're going to want to look up domain and range. Or maybe you want to look at the transformations again, or inequalities. Whatever topic that you're looking for, Khan Academy has videos. It basically has like worked out examples, and it has practice problems that you can do. There are so many kids in college that survive their math classes by using Khan Academy because their professors are just that awful. And maybe you feel like I'm that awful. I'm telling you that Khan Academy can save your grade. Or it can just be a supplement, is what I hope that it is. So, if you go to Khan Academy, one thing you can do is you can hit the search bar, and you can just type in whatever we're talking about or whatever you want more information on. But I want to show you what I think is great for this class. So if you go to subject, and I know it's going to be kind of slow because it seems like the more people that are on Khan Academy, the slower it goes. If you go to subject, if you just put algebra, yours might say like restart mission or pick up where you left off on your mission. But then you should get something that has this. So tell me if you see something. So subject, algebra, we'll just wait for it to get there, right? It's very slow. But I'll get you on there. Well, I don't either. I can get you the codes. I have them right here. Before the I'll at least show you and then have you get there. So, one thing you can search, but there's two big topics on here that if you click on, you're going to get most of this stuff. So if I scroll down, not introduction, not solving basic inequalities, but look at this one. Linear equations, functions, and graphs. And then look at the topics that are here that you can click on each one separately. You don't have to do the whole thing. But look at x and y-intercepts. So maybe you're like, I'm not good at x and y-intercepts. You can click on that. Slope-intercept form, graphing slope equations, writing slope-intercept equations, point-slope form, standard form. All of those are things that we did in this chapter. So if any of those are things that you're like, I need some more practice with standard form, I need some more practice with like 16 and 17, writing those equations, that's what you'd want to click on. Or maybe you're like, I feel really good with that. So scroll down a little bit more. So this is one I think you should look at. The other one is, you have to go down a little bit, but it's just called functions. And functions, there's a whole lot of stuff on here. And again, I don't expect that you're going to do all of this, but I just want to show you that evaluating functions, that's going to be like function notation. Functions and equations, that's going to be like, is it a function, is it not a function? Oh, there's more function notation. Notice domain and range, so if that's still an issue, right here. Piecewise functions, if you want some practice, which was not on the review, I feel like piecewise functions is something you could look at. And then we don't really need like a lot of this stuff, but notice, look at this, shifting functions, stretching functions. There might be some stuff in there that we haven't done, but definitely you can look at those transformations. Graphing nonlinear piecewise functions. I don't know if you need that or not. But anyway, these first things here and this, I think those are really good. We haven't found absolute value yet, but look right underneath there. Absolute value equations, absolute value functions, absolute value inequalities. I'm telling you, everything that we do in here is on Khan Academy. And if you're signed up for my class, everything you complete on here will go towards that percentage that can get you some extra credit. So what I want you to do today, since we have about 20 minutes left, is I want you to work on some of this stuff. If you have headphones, there's videos for everything. So like, let's say you click on piecewise functions. Everything that's a triangle is just a video. So maybe you're like, I just want to practice problems. I don't need the videos. You can skip those. If you are like, I have no idea what a piecewise function is, maybe you should watch a video. Everything with a star are actual questions that you can answer, and it'll tell you if you're right or wrong, and you can get hints on. So when you see a star, that's one that you can do. If you see a little book thing, that's like worked out examples. I'm sure it seem to be all like videos. But definitely really smart things to do if you're looking to study tonight is, and you can jump around on this, and Khan Academy will keep track of what you have done and what you haven't done, so you can still work on that percentage of completing it. Okay, so Khan Academy is not the only place that this stuff is out here, but it's really a good place, and so I just want to encourage you, as we get into harder stuff, that use Khan Academy as a great resource. Okay, so I'm going to get you some signed up and help anyone else that's not signed up. And then I'll pass back this quiz, right? And then I can everything you on this quiz every day. individual questions that you want to just ask me, or you want me to I just wanted to show you the content. It reports everything. I know that.